So we're going to start with an introduction to our next unit, and this is on quadratic equations. A quadratic equation is an equation whose highest power of the variable is a squared. So like for instance, your highest power is going to be an x squared in your equation. So we've actually been working on this a lot in our last unit. A lot of the equations and polynomials that we were factoring were squared. So we've actually been working with these, we've been solving these, we just didn't know it. This unit, we're going to focus more on what the graph looks like as opposed to solving it by factoring. So the parent function, so think of it as the most basic, the starter version of this quadratic equation is y equals x squared. So if we were to graph y equals x squared, I just did a quick little graph here, it would look like a U shape that's centered right around 0, 0, right in the middle of our on the origin, and is perfectly split by that y-axis. The shape it makes is something called a parabola, kind of that perfect smooth U. So all the equations that we're going to be working on this unit are all variations of that parent function, that starter version. So we might add something to x squared or multiply by something or subtract something, and that's going to change its shape or it's going to change its location by moving it around in order to give us a variety of different types of equations. But they're all built off of that y equals x squared. The key part of our graphs are going to be something called our solutions, or sometimes we call them roots or zeros. This is exactly what you were just finding last unit. So when you would factor your polynomials and then set those equal to 0, what you were finding were the solutions, the roots. Another way to find those same answers is by looking at the graph. So our roots are where it crosses the x-axis. So these points here on our graph are our roots. So in this case, it crosses at -1 and it crosses at 3. So we put those in our braces, and that's our solution set. -1 and -3 are the solutions to that particular quadratic equation. So we're kind of looking at where does it cross the x-axis. All right, bottom little section here. So now we're going to look more specifically at our graph and some key pieces of information. So the first is something called the axis of symmetry, or sometimes you'll see it abbreviated as AOS. It's a line that divides the parabola into two mirror images. Basically think of it as it splits it perfectly in half. It's always going to be a vertical line, and it's going to go right through that center point of our parabola. Because it's always a vertical line, it's always going to be the form of x equals something. So whatever x value that line goes through, that's the equation for that vertical line, x equals that number. Where that axis of symmetry hits our graph is something called the vertex point. So it's the highest or lowest point of our parabola, sometimes we'll call it a maximum or minimum, and it's where those two lines intersect, or I like to think of it as the turning point. So it's that center point in our graph. So in this left one here is this point right down here, or on the right one is this one up here. So I always think of it as it's kind of where it changes from going up to going down, or from heading down where it turns and starts heading back up again. That's our vertex point. All right, so flip to the next page and let's try these first two together, and then you're going to try a couple of them on your own. But it's just starting to identify some of these key pieces of information from our graph. So from our first one, we want to find our maximum or minimum point. Well, since this graph turns down, my point, we call it the vertex, is a maximum point because it's at the top of our graph, and it's at the point 4 and 2. Our axis of symmetry is that line that goes straight through our vertex that perfectly splits our graph. Since it goes through x of 4, our equation is going to be x equals 4. And then our roots, or our solutions, are where it crosses the x-axis. So in this case, we cross right here at 2 and at 6. So our solutions, or our roots, are 2 and 6. Those are the x values that give me a y of 0. So let's look at the second one. This one's a little tougher just because the scale is a little bit harder to read. So you'll find that that vertex is kind of right in the middle here of -1 and -2, so let's call it -1.5. And it's a minimum point Again, this is called our vertex, but it's a minimum because that's at the bottom of our graph. And then I think it looks like we're counting by 2's as we're going down. So that would be negative 12. Our axis of symmetry is going to be that line straight down the middle of our graph, right through that vertex. So it's going to be x equals negative 1.5. You'll notice this number and our x value are always going to be the exact same. And then our roots. Well, it looks like it crosses right here and right here. So it looks like we have roots of negative 5 and positive 2. All right, so there's 2 more on that page and then a couple on the following page. Go ahead, take a couple minutes, give those a try, and then we'll go over them all together.